All right, so today we're moving on with our transition matrices. So yesterday we looked at setting them up and how and we're going to use them now. So transitions are used to predict maybe what is happening in the future. So considering our early example of going to the movies or staying home, we saw that we had a transition matrix and its transition diagram. So here is like the transition diagram. So sometimes they ask you to draw that from the transition matrix. So I've seen that done in tests and exams. So be wary of that. So we looked at that yesterday, and remember the things that we knew about our transition matrix. Remember they add up to 1, the columns, and we knew that percentages got changed to decimals, okay? All right, so using this information alone, a number of predictions can be made. So what they're going to tell you is like they will tell you how many people they actually have, all right? So here in the example, they say we've got 200 people. So we often say when like they say that, we often say n, so n equals 200, the number of people. And it says if 20%, it predicts that 20% of 40 of these people will go to the movies next week. So you see, so when they say that, so they said there's 40 people at the movies, and we can see that 20% will go to the movies again. So you do 20%, 20% times 200 equals 40, and that's how they got it. So when they saw 80% of the people will go from the movies to staying at home. Was it staying at home? And that ends up being 160. So we did a little bit of this yesterday in the thing. So we go through and you can see further, if 150 people stayed at home this week, and then the transition matrix predicts. So we can just work out different things if we're told. But what we want to do is we want to keep on using this transition and find out, predict in the future. So let's just go through these questions, and it will come to us a bit more when we do our examples. All right, so the following transition diagram can be used to describe movement of children between the Ferris wheel and the merry-go-round, and here we've got it. So we'll just go through the questions. So A firstly says, what percentage of children on the Ferris wheel are predicted to go to the Ferris wheel next time? So what's Ferris to Ferris? What percentage? If we look, yeah, good, 80%. If we look at number 2, if they're at the Ferris and they're going to go to the merry-go-round, what would that be? 20%. Good. Okay, then we've got B. It says 140 children went on the Ferris wheel. So we had 140 children at the Ferris wheel. How many of these are expected to go on the Ferris wheel next time? So if you look at that, so really what we're saying is we know that Ferris wheel to Ferris wheel was 80%. So if there's 80% of the 140 people at the Ferris wheel or kids. So what you do is when you say you change the 80% to a decimal, which is 0.8, and you change of means times. In maths, if you ever say something of, it means you're timesing. And then we times it by the 140. And then, so if you do that on your calculator, if you want to, so we get 112 kids. And then it says, of the one about still at the Ferris wheel, the kids starting at the Ferris wheel, how many will go to the merry-go-round? So we go, all right, that's 20% of that 140. So we'll do 0.2 times 140, which equals, what's that? A 28. Okay, so then it says if 140 children went on the Ferris wheel and 80 children went on the merry-go-round, how many children do you predict will go on the Ferris wheel next time? So if 140 children were on the Ferris wheel and 80 went on the merry-go-round, so you're really just looking at how many will. So you have to think about it. So this is a little bit trickier because you think we've got to see who's going to go to the Ferris wheel. So remember, you've got the kids that will go that Ferris wheel to Ferris wheel. So if you've got 140 at the Ferris wheel, so then you're going to times it by the F to F, which was 80%. All right, so that ends up being, we saw that was 112. But then also you've got the kids that were at the merry-go-round who are going to go to the Ferris wheel. So if you look at that, that was, they said that there was 80 kids at the merry-go-round. And what percentage are going to go merry-go-round to Ferris wheel? What was it? No, merry-go-round to Ferris wheel. M to F is 30%. So we'll times it by 0.3. So if we do 80 times 0.3, we get 24. So the total kids going to be at the Ferris wheel the next time will be those two added together. So that's 136. Okay. So it can get it's going to get annoying if we have to do all this. So what we're going to do is we'll set up using matrices and the transition where we can just predict how many at each of the states using it. So let's have a look at that. So the following transition diagram could be used to describe choosing between hot and cold meals in a previous. So a customer who purchased hot food today, what percentage of the people would expect to buy hot meals tomorrow? So we're just looking at this. So what we want is hot to hot. What percentage is that? Yeah, so we've got 90%. B, it says if the store sold 400 hot meals on one day, how many of those who purchase hot meals do you expect to purchase hot meals the next day? So you're saying we know hot to hot is 90, so 90% of 400. So it's going to be 0.9 times 400. Yeah. So 360. Good. And then C, if the store sold 400 hot meals and 500 cold meals on one day, how many hot meals in total do you expect to sell them to sell the next day? So you knew that this is where we've got to get the hot to hot, and then we also have to get those who are going from cold to hot. So up here we knew we said hot to hot was 90%, and there was already 400 at hot. So that's pretty much doing that sum we did before again. And then we've got to look at the cold to hot. So cold to hot is 40%, but how many people or cold meals did they sell on the day? It was 500. We had different amounts sitting at the so we've got 0.4 times 500. So equals 200. Yes? No? Yeah. And then we've got a total of 560 if I add them up. So there's our answer. So we could have to keep doing this. Now, when there's only two, our transitions can get bigger. We can end up having a 3x3. So this will get, it'll get a little bit harder. So our next lesson is where we will look at how we do it with matrices. But we're going to leave it there, and you guys can finish 4G now.